All right. Good morning, good afternoon, good evening, or depending on your time and your location. I'm Engineer Moses Unafe. Today, we want to discuss about effect of current on human. Effect of current on human. I want us to understand that electric shock occurs when an electric current passes through the human body, potentially causing a physiological harm or even death. The severity of shock depends on several interrelated factors, that magnitude of current and its effect on the body. There are factors that affect the magnitude of electrical shock in a human body, and we are going to take them one after the other. One of these factors is voltage level. A higher voltage increases the potential for current to flow through the body. A low voltage shock, e.g., body resistance. The human body offers a resistance to current flow, primarily through the skin. A dry skin has a high resistance up to 100,000 ohms, while a wet or broken skin can reduce a resistance to as low as 1,000 ohms. Internal body tissues, blood, for example, muscles, have much lower resistance, allowing current to flow more easily once the skin barrier is breached. So, another factors affecting the magnitude of electric shock in human body is current path through the body. The route the current take significantly affects the outcome. The hand-to-hand or hand-to-foot path can pass through the heart or lungs, increasing the risk of ventricular fibrillations or respiratory arrest. A current that avoids vital organs may cause a localized burn or muscular contraction, but are less likely to be fatal. Another factors that affect magnitude of electrical shock is a duration of exposure. A longer contact with increase of amount of energy transfer or the severity of injury. Even a low current can be lethal if sustained for a several seconds. There are also factors that affect the magnitude of electric shock. One of it is the type of current. We have two types of current here, the AC and the DC. An alternative current, AC, is more dangerous than the direct current, DC, at the same voltage. And AC can cause a muscular tendonic or sustained a contraction, making it difficult to let go of the source. An AC at 50 to 60 Hz, common in household power, is particularly hazardous to the heart. The current magnitude, the actual current measured in ampere, determine the physiological effect. The current in milliamps affects a human body. Take, for instance, 1.5 milliamps. It can tingle a sensation only. Then from 5 to 10 milliamps is painful shock Then from 10 to 20 milliamps is muscular contraction. Then from 20 to 100 milliamps is respiratory paralysis. And when it's above 100 milliamps, is ventricular fibrillation death, of a ventricular fibrillation or death. Now, these factors are also, environmental factor is not included. Environmental condition, sometimes a wet environment, e.g. like maybe bedroom, outdoor setting, drastically reduce skin resistance. A mental surface conductive footwear or a standardized water increasing the risk of several world shock. Individual factors. Individual factor is also another factor. A body size, the size of the body, the health condition, e.g. the heart disease, or age can also influence a sustainability. Children and elderly individuals may be more vulnerable to lower current. Now, the effect of current on a human body. I want us to take, for example, what we are familiar with. For example, a typical day-to-day intervention with electricity is our phone charger, which is approximately 5 amps, 6 amps, as the case may be. And if it is a fast charger is 6 amp, minimum from 5 amp to what? To 6 amp. Why our socket outlet, well, we are almost familiar with every day in our appliances, is 30 amps to what? 15 amps. Now, let's do a calculation to know how the effect of our electric current on a human body. Now, assuming that the average human resistance is 1,250 ohms. Therefore, according to ohms, V, which is voltage, is equals to current times what? Resistance. And for us to calculate current, we have to make I, which is current, the subject of the formula. By so doing, our current is equals to voltage divided by what? Resistance. So now, if you are exposed to like 400 volts, if you are exposed to 400 volts, guess the amount of current that is going to flow through your system. And for us to calculate this, you apply the formula, which is current equals to voltage all over what? Resistance. So therefore, 400, which is the voltage across the body, and divide by the resistance of the human body, which is assumed to be 1,250 ohms. When you divide this, the outcome is going to be 0.320. When you multiply with 1,000, it's going to give you 320 milliamps. So the current that will flow through your body when you are exposed to 400 volts is going to be what? 320 milliwatt amps. Now let's come back to the effect on 320 milliamps. Now at 100 milliamps, you're already exposed to ventricular or fibrillation, which is death. Now, if it is 400 volts, you are exposed to 400 volts, that is to say, is death totally. Now, let's take, for instance, you are exposed to like 230 volts of AC. If we are to calculate this, our current voltage is equal to 230 divided by the human resistance, which is 1,250, which is going to give you 184 milliamps. Now let's bring it down a little. Let's say you are exposed to like 50 volts. If you are exposed to 50 volts divided by 1,250 will give us what? 40 watt milliamps. So if you look at 40 milliamps in our previous explanation, you see that as from 10 to 20 is muscular contraction. From 20 to 100 milliamps is respiratory what? Paralysis. That is how dangerous exposing yourself to electricity is. Now, take for instance, you have a charger of 5 amps. If you calculate it, you're going to know how effect it will be in your what? In your system. I want you to share this video so that others can as well gain knowledge. Thank you.